So, if we start off with a nice round ball of clay, we can split it into 2 equal pieces. If we take those 2 pieces and split them up again, we get 4. So can we keep doing this forever? Or is there some point at which we end up with a bit of stuff that can be made no smaller? So it turns out that the universe actually does come in little pieces. And inside each and every one of you, there are about 10 billion atoms, ranging from the lightest element, hydrogen, to heavier elements like carbon and oxygen. So are atoms as small as it gets? Well, if we look even closer, we find out that even atoms are made up of tinier pieces. And to help us along, I've brought along some plasticine models of all of the little bits of stuff that make up the universe as far as we know it. So meet the standard model. Here it is. So if we take ourselves on a journey inside the atom, the first thing we discover are electrons whizzing around a nucleus of protons and neutrons. And these electrons are held in place by the electromagnetic force. And the particle that does that job is called the photon. These are little packets of energy. And if we go even further still, we reach the nucleus. We're inside protons and neutrons. There are little particles called quarks. And in normal matter, those are called the ups and the downs. And those are held together by bits of subatomic cement called gluons. And those are the carriers of the strong nuclear force. And sometimes quarks can even change types. And when they do this, they use the weak nuclear force, and they spit out very heavy particles called W bosons. And this happens all the time inside our sun. And when the W's decay, they produce super elusive particles called neutrinos. I'm going to lose this guy. But these are so shy that about 10 billion of them pass through your thumbnail every second. Anyone notice? So electrons, quarks, neutrinos, and a whole bunch of force-carrying particles. These are the indivisible lumps of stuff which make up the universe as we see it. We can chuck in some heavier versions of the electron, neutrinos, and quarks. When I say heavy, I really mean heavy sometimes. The top is huge. And that's the standard model. So is this all there is? Is particle physics a done deal? Basically, why do I still have a job? Well, one very important force is still missing, and that's gravity. And this is a problem. Another problem is that the Higgs boson that was discovered last year at CERN, here it is, although it's heavy, isn't as heavy as it naturally could be. So what we've done is build the Large Hadron Collider at CERN in an attempt to try and understand these mysteries of the universe. And by colliding beams of protons thinner than a human hair at immense energies, we can actually create new particles which didn't exist in the universe before, purely out of that energy. And we hope that in the next few years, we'll have enough energy at the LHC to produce particles which no one has ever seen before.